Today I'm going to talk about the mastering of the complexity of version management in simulation data management, and I'll also talk a little bit about AI-driven assistance in that area. So first of all, let me introduce what is SDM, and I think we heard a lot about it in the talk of Mr. Pohl and in the challenges. And I think we can actually solve many of the challenges that have been introduced there. Even so, I will focus on my talk, I'll focus on version control, so that's similar to what Mr. John did with Git. We do that also in the SDM system, and we'll focus on that. So SDM system we saw that about setting up simulations. This is what our colleagues from Better showed, and then storing all that data in the SDM system, and then actually also monitoring. And the goals for this is obviously collaboration, and we'll come to that later. What tools do we need for collaboration? Traceability and integrity of all the data, enforcing some standards on the users, and by this gaining time savings, and also democratization, enabling simulation for all engineers in the company. And I think we have a pretty scalable solution at hand, which is very flexible for integrating pre- and post-processing tools such as ANSA, HyperMesh, Primer, and so on, which is solver agnostic, so you can actually handle crash simulations in the system the same as CFD simulations or multi-body simulations, and so on. And we also have very open APIs which come into play if you want to integrate AI and machine learning use cases in your workflows. So, but let's come to mastering the complexity of version management in an SDM system. So, the challenge in an SDM system is that you have countless CAE model iterations. In the slide of Mr. Pohl, this was called development loops. And I'll come to that a little bit later also. But not only you have this countless CAE model iteration, you also have a collaboration between numerous users. They may even be spread worldwide. So we saw that also on the slide of Mr. Pohl, where they have locations all over the world, and the work of these engineers have to be coordinated. Or Mr. John also reflected on that, and where they use Git to actually synchronize the data between the different persons that are working with that. So by challenging the complexity in an SDM system where you have to actually keep all that versions. And what we want to do with AI-driven assistance is we want to streamline this process and to further facilitate it for the user. So it becomes easier and much more fluent to work within the SDM system. And by this, augmenting the information which is stored in the SDM system and also redefining the discoverability. I'll come to that later also on the slide. And improve overall the collaboration between the engineers and the team. Okay, CAE model evolution. So I'll just focus on this development loops, which we saw in the previous slide. So once you have already set up your base version of your model, where you imported the CAD data, meshed it, created a real model, which can be a quite complicated process by itself. On its own. So then you start a simulation, you identify a problem. Okay, then you think of some improvements, you apply the improvements, you get a new version, you run a new simulation, and then you verify if your change actually did some improvement, and if so, if not, you discard this version, and if so, you can continue with further improvements. So you run a new simulation, identify other problems, and this process you're going to repeat over and over again. And you're not only doing it alone, you're doing it in a team with tens, with hundreds of engineers, all of this at the same time. So in a simulation data management system, you have to reflect that all by versions. So what you see here is kind of a mind map. We call that big history graph in our SDM system. So it's like the versions that we saw in Git. Yeah, and the same process here. I'm starting with the first base version. I'm creating 4 changes, run the simulations, And then I choose which one was the best. So maybe this one was the best version, which actually did some improvement. And then I'm publishing it, and I repeat the process. So now this is my base version. And from this base version, I'm now deriving even more changes. Maybe some others in my team joined also, so I'm not alone anymore, and I can do many different things, can try out whatever helps. And maybe this time we have one working on the roof structure here, and we have another guy who's working on the floor structure, and both of them are improvements. So now I have 2 base versions for my next iteration. And in my next iterations, I'm creating other changes based on this version and based on that version. And the point that I want to make this is a very simple example. If we come to an OEM project and we have among our customers, there are some bigger OEMs, then they have not like 30 versions, which you see here. They have, during the whole vehicle development process, they have like 20,000 versions of these. And this can be quite challenging, actually, to handle all that data and to make that. So my point is, at the very core of an SDM system, you need a very robust version management. And what we did is we implemented something which is very similar to the approaches that you know from Git. So what Mr. John talked about in his talk was actually giving us ideas at the time we implemented that. So, but why do you need version management? Actually, you want to capture and document everything that you did, because this is actually knowledge. If you did a change, you need to describe the change, you need to describe why you did it, your intentions, and you need also to describe what actually was the outcome. Was it good? Was it not good? And you need to describe that. And this enables the discoverability of your knowledge later on. And this is something that we'll need later also for the AI assistants, because without actually putting the data in a form where the AI can do something with that, it's worthless. Okay, so what we did is we versioned everything, like each component. This can be solver includes preprocessor files, material, control cards, configurations, and so on. But we also versioned parameters and process scripts. So usually are processes tied to the data, like pre-processing step where you apply certain material characteristics afterwards automatically, or post-processing script, which are handling the extraction of key results, curves, videos, and so on. And these are usually tied to the data, so they are also versioned. And on top of it, the whole project is versioned by itself. Okay. In our vision, or at least in my vision, it's very important that you support the users of an SDM system with powerful tools to actually navigate all these versions. So we have different means for that. For example, we have something that we call Railgraph. You saw that also in one slide of Mr. John in his GitLab repository, and actually we have the idea from that. So when you click on an object and you see instantly all the versions, you can use that for navigating back and forth through the versions. You can see the different branches, you can see which versions is based off of which version, and you can use that in navigating actually your data and see what your colleagues do and decide where you want to base your changes on. And then we also have something that we call big history graph. And the big history graph is like a mind map where you can zoom in, zoom out, where you have more detailed insights on your changes, where you can see summaries of what you changed actually. And where you can also get a big picture with a time scale here on the right side to see which change had been done, and you have all kinds of filters to search through the data. So, but these are only classical filters for now. We also have, but I don't want to dive deep on it, tools for comparing and for merging. So this is actually a powerful tool for going deep in. And recently we also introduced 3D previews of what you change. So every time that you change something, there is a 3D preview model generated. This is a Google format, which is very small, like JPEG, but it's in 3D because the data that the engineer works with is 3D, and it's stored in such a way that you can even choose different versions here and compare them. So you can see, for example, if you click on one and then on the other, some parts are red from the one version, some are orange from the other versions, and you can actually understand right away what is the difference between that version and decide which version are you going to base your changes on. Okay, but what the heck has this to do all with AI? I'll come to that next. And before I do that, I will just introduce AI and simulation data management. So one area of where AI can be used in simulation data management is everything what we learned from simulation results. And we have seen many talks on this conference also on that topic. So this includes simple forms of data analysis like regression models. So there were multiple talks on that topic. Or event detection, such as CDACT and Sky are doing with their tools, where you detect unwanted behavior automatically. And you can do time series classifications. We also have a paper on that one for automatically labeling curve data, for example, because in a simulation data management system, you are needing all this curve data, and it needs to be labeled correctly. And you can all kinds of data-driven reduced order models or physics-informed neural networks. So in this talk, I'm not talking about this kind of AI. And then there is this LLM-based AI, like the generative AIs, the ChatGPT kind of AI. And what can this be used for in an SDM system? And I have some use cases here. One which is very simple, create a chat assistant for talking with the documentation. So a very early stage of this is a chat assistant where you can actually talk with the user manual of our SDM system. And since the user manual also has the documentation on our GraphQL interface, on our REST APIs, you can even ask it to write a script to retrieve certain data, and it will write you a script in Python to retrieve data from the SDM system. So this is very straightforward to set up. It's using a RAG system, and we will release that for our manual within the next month. Another thing, and that's what I'm going to talk about right after this slide, is a system for assisting the creation of change documentation. So actually, this is a little bit more integrated in the SDM system, and it's for actually already creating some useful data. And then there are use cases where you can create integrations in the CAE pre-processing tools. I'm sure ANSA has some AI capabilities for meshing, for example, and for other stuff. But this is not our area. We are not preprocessor developers. What we see, for example, also with our software developers, that they use Visual Studio Code or PyCharm, and they have like powerful chat system integrations in there, like write doc strings, create a commit message for me, and easy stuff, but it actually helps them to be more effective. And as an outlook, also, we saw that, I think in the talk of Mr. Garke, it's the search and summarization capabilities that these models can provide. So what you can do is you can put all the information that you have in the SDM system, whether it's documentation, whether it's information about the changes, you can put that in a RAG system, and then you can actually ask the chatbot, where do I find a car where something at the B pillar has been optimized? So stuff like that. So this is pretty straightforward. As an outlook, but we are also going to look into that in the future, is to perform complex tasks within the SDM system. So, and this is about agentic AI and tool use with LLMs. And our plan is to implement an MCP server on top of our SDM system, and that we can actually expose that to large language models for actually doing use cases where you can say, okay, I need to copy all this kind of data from project A to project B, but please modify the certain metadata while you're copying it, stuff like that. Okay, so, but back to change documentation and version control. So, the change documentation, so documenting what a user has done in a change, is very key for the SDM system. Without this, you don't have the information that you need for the traceability, for discovering actually your data. The problem here is writing change documentation is boring. Yeah, it's very boring, and nobody is doing it. So people are just putting in some weird stuff, and yeah, the consequence, change documentation is bad, and knowledge is lost. So we need actually facilitate the change documentation or creating change documentation. And what we did is we introduced a very small button. It's small and it's actually easy to implement, but it's now there. It's an AI assistant for helping the user with the change documentation. And if a user presses this button, the change documentation will be augmented by information that can automatically be extracted from the change between the two models. So this is a small feature actually, but users are really happy about it because it's so boring to write change documentation. What we also aim at, and this is for the research project that Mr. Garke mentioned, the Safecar ML, and it's more in the research of Fraunhofer's guy, that AI models are capable of understanding the semantics of what has changed. Like a hole has moved from the left to the right, or a bead has been extended by a certain amount of millimeters, or something like that. So, but this is maybe to come. So the pipeline for what we did already is like this. You have a problem, you apply your change, you get a modified version of your model, and then you are prompting the user of what he did. So at least you try to get something meaningful out of the user. And he'll just provide some very simple comment which will put the change into a context. And at the same time, you're running a tool like Model Compare, which is from Fraunhofer Sky, which automatically extracts the changes on that it can from the change here and puts that into a JSON file. And then you use both of this information and you put that into a prompt for an LLM model. And then you send the prompt to the LLM. So if the user hits the AI button here, which is only for the change documentation, so it's a simple use case, the model is requested and an augmented change is created which holds some more information, some easy information where the user may have been too lazy to write it up, like the part name, like the thickness has been changed from 1.5 millimeter to 1.6. Yeah, he would only write, change the thickness of the B-pillar, but he's missing information there, and you can augment that at least. And obviously in the future, we will also hopefully be able to augment it by information. The hole has been moved 5 centimeters from the left to the right, or something like that. Okay, and this is something we do in the Safecar ML research project. And in order to do this latest thing, creating this semantic description, our part in the Safecar ML project is creating a data set where we actually try to implement changes, geometrical changes on body and white structure, on a vehicle structure, where we actually do these things like moving a hole, extending a hole, moving a bead, and stuff like that. So we have examples for training data, but we are not going to create so much data that we can actually train a base model, which is out of scope. We do not have the financial backings to do such a thing. But what we can actually do is create a data set for large language model fine-tuning. So in fine-tuning, what you do is you take a base model, like DeepSeek R1, for example, and then you are doing fine-tuning on top of it. And for this, at least we think already a small data set, maybe a couple of hundreds well-documented changes should be sufficient. And as Mr. Garke pointed out, this data set will also be made available publicly, so whoever wants can later extend that or use that for research or whatsoever. Okay. So with this, I'm almost at the end of my presentation. I have outlook and conclusions a little bit, and in the outlook, I want to show use cases that we are currently working on. For example, one part of the SDM system is also where the results are. And so here you see, like, the user has selected one result, and here on the right side, he can see a report. A report for a typical simulation usually is multiple pages long. So one thing that we are actually currently implementing is that the user can hit here a button and say, okay, create a summarization of this report. So this is a very typical use case for a large language model, and it actually helps the user to even quickly understand what's going on in this, or if there are certain outliers or stuff like that. So it's just an example. What we're also going to research into maybe a little bit later is how we can use thinking models like the DeepSeek R1 or the O3 Mini. These are thinking models which have a chain of thought, and how we can use this model in the case that we give them more context. So we give them, for example, the last 30 versions, everything that has been changed and everything that has been written up in the summarization of the observations. And then we request, okay, now you know that. What are your suggestions on the next steps? Not sure if that will have some meaningful outcome, but at least we're going to research that a little bit. And what we're also going to research is automatization, to use LLMs for automatization in the SDM system, meaning agentic AI or tool use, where you can create something like an MCP server, which is exposing something like an API to the large language model, and then the large language model can use it for discovering data within the SDM system, for example, or performing simple tasks within the SDM system, like collect all simulations where the head integer criteria was above something. So in total, we think that LLM-based AI will have a place within SDM systems, but it will not take over the SDM system and will make simulation obsolete or the work of simulation engineers. However, it will be all kinds of small tools for the simulation engineer to facilitate their life while working within the SDM system. And by that, we are creating better documentation within the SDM system and making the data more usable also. And for the user, yeah, I think you know what I wanted to say. Thank you very much. I'm done with my presentation.